So I'm going to start Green's theorem in this video, right? So far we have finished line integral. So first we started with gradient, and then divergence, and then curl, and then we have seen some vector identities, and then we have moved on to line integral, right? Yes. So now we are going to see what is meant by Green's theorem, right? So Green's theorem, what Green's theorem says is that, so it connects the relation between line integral and the surface integral, right? So far we have seen line integral. Now what Green's theorem says is that it tells the relation between line integral and the surface integral. So what Green's theorem says is that, so integral over C m dx plus n dy, right? So this is line integral. So m dx plus n dy is equal to double integral over r. So this is our region R, dou n by dou x minus dou m by dou y into dy dx. This is what Green's theorem says. Yes. So what Green says is that the line integral is same as the surface integral, dou n by dou x minus dou m by dou y dy dx, right? Yes. So we will do some problems. So in order to evaluate a line integral, we can also evaluate this, right? So just remember the formula that integral over C m dx plus n dy is same as double integral over r dou n by dou x minus dou m by dou y dy dx. And the important thing is here r, so here we will have y limits, right? Here we y limits, and here we have x limits, right? And remember, this x limits has to be some number like a to b, and y limit has to be a function of x, right? So y limit can be some p of x to q of x. It has to be a function of x, right? So remember, when you are finding the y limits, it has to be a function of x, and when you are finding the x limit, it has to be a number, right, like a to b. So we will work out problems. So first problem is verify Green's theorem. Verify Green's theorem for double integral over C xy plus y square dx plus x square dy, where C is the closed curve, of the region bounded by y is equal to x, y is equal to x square, right? So this is what the theorem. So we need to verify Green's theorem, right? So that means we need to find LHS, and then we need to find RHS, and we have to say both are equal. So first we will find RHS. So what is RHS? So RHS is double integral over r dou m. Okay, first it is nothing but dou n by dou x minus dou m by dou y dy dx. This is our RHS. Now when you compare this with LHS, you can see m dx plus n dy, right? So compare this with this. So we have m is equal to xy plus y square, and n is equal to x square, right? You can see m dx plus n dy. So m is xy plus y square, and n is x square. Now we need dou n by dou x and dou m by dou y. So what will be my dou m by dou y? So it is nothing but x plus 2y, and dou n by dou x is 2x. So this will become double integral over r dou n by dou x is 2x minus dou m by dou y, which will be x minus 2y into dy dx. Now this is nothing but double integral over r. So 2x minus x is x. So x minus 2y dy dx. Right? Yeah. Now we need to find the limits. Right? Yes. So you can see the C is a closed curve bounded by y is equal to x and y is equal to x square. From this information we need to find x limit and the y limit. So we can see and we know that y limit has to be function of x and x limit has to be a number. Now we can see that y is equal to x is 1 and y is equal to x square. So this is our C, right? So this is our R, sorry. This is our R bounded by y is equal to x. So this is y is equal to x and this is y is equal to x square. So we're going to travel in this path, right? Yes. Now what is the point of intersection? We need to find this point and this point. A point of intersection gives x value and the y value you can see it varies from x to x square. So what will be point of intersection? We have y is equal to x square, y is equal to x. That means x is equal to x square, right? So I'm just substituting y is equal to x here. That means x square minus x is equal to 0. If we take x common, you will have x minus 1 is equal to 0. X is equal to 0 comma 1. Right? So when x is equal to 0, y is equal to 0, right? Because y is x square. And when x is equal to 1, y is also 1. Y is also 1. That means 0 comma 0 and 1 comma 1 are the points of intersection. Now we need to find x limit and the y limit, and as I said that x limit has to be a number. You can see x varies from 0 to 1, right? This is 0 to 1. So for x limit we have 0 to 1, and for y limit we have two bounds, right? So y limit varies from y limit varies from x square to x. So this integral will be, so x will be from 0 to 1, right? X will be from 0 to 1 and y has to be a function of x. So when I define Green's theorem, I have said y has to be a function of x. So you can see x square x. So x square x minus 2y into dy dx. So when you integrate this, you will get the RHS, and LHS is very easy. LHS is same as, LHS is nothing but a line integral which we did for the last two classes. So we need to evaluate this integral. So integral 0, right? 0 to 1. So 0 to 1. So when I integrate this with respect to y, so we have x times, so integral dy is y, so this is x square x minus 2 times, and this is y dy is y square by 2. So integral x square to x dx. So this will be integral 0 to 1 x into x minus x square, upper limit minus lower limit, and this 2 will get cancelled. So when I substitute x, we will have x square minus, and upper limit is plus x power 4 dx, right? I'll just substitute upper limit minus lower limit. So the upper limit is so we need to evaluate this integral, right? So as the upper limit is x square and the lower limit is x square. So we have x square minus x power 4, and here we have minus a, so this will be plus. So we need to evaluate this integral to find the RHS. Now this is nothing but integral 0 to 1 x into x is x square minus x cube minus x square plus x power 4 dx. You can see this 2 will get cancelled. So when you integrate this, we will have minus x cube is x power 4 0 to 1, x power 4 0 to 1 plus x power 5 by 5 0 to 1. So this is nothing but minus 1 by 4 plus 1 by 5, right? Minus 1 by 4 plus 1 by 5. So under LCM we have minus 5 plus 4 by 20, nothing but minus 1 by 20. So therefore minus 1 by 20 is our RHS. So RHS is double integral over R dou n by dou x dou m by dou y minus dou n by dou x minus dou m by dou y, right? So we have found RHS. Now we need to find LHS and we need to show that LHS is also equal to minus 1 by 20, right? Yes. So what is our RHS? So RHS is nothing but, so we have shown that, we need to find LHS now. So we have shown that this is equal to minus 1 by 20 and we need to find integral over C m dx plus n dy and we need to show that this is equal to minus 1 by 20, right? Yes. So first we need to evaluate. So this is our we have proved this. Now we need to find this, right? So we need to find integral m dx plus n dy. Now you can see our this is a line integral, right? So we just need to solve, which we did in the previous methods. So we have y is equal to x and y is equal to x square. Y is equal to x square. Now what I am going to do is, so this is nothing but 0 comma 0 and this is nothing but 0 comma 1. So first I am going to take this path and I am going to take this path, line integral, right? Is it clear now? Is it clear now? Is it clear now? Yes. So now we need to evaluate integral over C m dx plus n dy. So we have shown this is equal to minus 1 by 20. So this I am going to find like integral C1 plus C2, where C1 is y is equal to x square and C2 is y is equal to x, right? Yes. So we are going to separate into two parts. So again this is nothing but line integral. So we have solved lot of problems line integral. So first we will find C1. So C1 is integral over C1 m dx plus n dy. So you can see our m is it is the question, right? So our m is m dx plus n dy. So this is nothing but xy plus y square dx plus x square dy. This is our C1. Now we have to change everything in terms of x or y. So for C1 we have y is equal to x square. That means dy is equal to 2x dx. So x varies from 0 to 1. X varies from 0 to 1, right? So this will be integral over 0 to 1 x into, so in place of y I am going to substitute y square, and again in place of I am going to write this as x power 4, right? X power 4 dx plus x square. So in place of dy I am going to write 2x dx. So this will be integral 0 to 1 x cube plus x power 4 plus 2x cube dx, right. So everything is dx. So I can combine these two terms. So this is nothing but x cube plus x power 4 plus 2x cube. So you can see this 2x cube will be 3x cube. So integral over this will be 3x cube plus x power 4. So when I integrate this, we will have 3 times x power 4 by 4 plus x power 5 by 5. The limit will be from 0 to 1. So when I substitute upper limit minus lower limit, we will have this is nothing but 3 by 4, and this is nothing but 1 by 5. So when I make a LCM, we will have 15 plus 4 by 20, so which is nothing but 19 by 20, right. So our C1 value is 19 by 20, so this value is 19 by 20. Now we need to find C2. So C2 is y is equal to x. So for y is equal to x, so just for C2, so you will find C2 now. So this is C2, this is C2. Again for C2 y is equal to x, so therefore our dy will be dx, and again x varies from 0 to 1. Sorry, our x varies from 1 to 0, right. So for y is equal to x square, we are moving like this, so I mean 0 to 1, and for y is equal to x varies from 1 to 0. X varies from 1 to 0, right. So everything will be changed now. So we have x into y is x plus y square is x square dx plus x square dy is dx. So this will be integral 1 to 0, right. Integral 1 to 0, integral 1 to 0. This will be x square. So x square plus x square will be 2x square. 2x square plus x square will be 3x square. So we will have, I can take 3 outside. So 3x square dx. This is nothing but 3 times x cube by 3. The limit is from 1 to 0. So 3 will get cancelled. So we have minus 1, right. 0 minus 1. So we have shown that this value is minus 1. So what will be my integral over c m dx plus m dy? So therefore integral over c will be 19 by 20, and this value is minus 1. So when I make a simplification, we will have 19 minus 20 by 20, which is minus 1 by 20. So again you can see this also minus 1 by 20. So we have proved that the LHS is equal to RHS. That means Green's theorem is verified. So we'll move on to next problem. So next problem is the next problem is a second problem. So verify Green's theorem for integral over c x square minus 2xy dx plus x square y plus 3 into dy, where c is the boundary of the region, where c is the boundary of the region y square is equal to 8x and x is equal to 2, right. Y square is equal to 8x and x is equal to 2. Now first we need to find the point of intersection to find the x limit, and you can see the y limit is y square is equal to 8x. That means y is equal to plus or minus root 8x. So you can see, so y square is equal to 8x means it is open rightward, and x is equal to 2. X is equal to 2. This is x is equal to 2, and this is y square is equal to 8x. Now we need to find the point of intersection, this and this, right. Yes. So this is a line of passing. So we are going like this and going like this and going like this, right. So we need to find this point and this point, right? We need to find the point of intersection. So for point of intersection, you can see first we need to find point of intersection. So it is given that y square is equal to 8x and x is equal to 2. So from this what I can conclude is, so if I substitute x is equal to 2 here, we have y square is equal to 16, that means y is equal to plus or minus 4. That means for x is equal to 2, we have y to be equal to plus 4 and minus 4. That means the point of intersection is 2, 4 and 2, minus 4. So this is nothing but 2, 4 and this is nothing but minus 2, sorry 2, minus 4. 2, minus 4. So, right? Yes. Okay. Now we need to find LHS and then we need to find RHS. So we need to find double integral over R dou m by dou n by dou x minus dou m by dou y into dy dx, right? So what is m here? So m is x square minus 2xy and n is x square y plus 3 dy. So integral over c m dx plus n dy. Yes. So this will be integral. So we need to find x limit and then y limit, right? So you can see y limit is nothing but y is equal to minus root 8x to y is equal to plus root 8x, right? So here y is equal to 8x, that means y is equal to root 8x and y is equal to minus root 8x, and x varies from 0 to 2, right? X varies from, so this is 0 here, so you can see x varies from 0 to 2, right? Yes. So x varies from 0 to 2 and y is equal to minus root 8x, and we need to find dou n by dou x and dou m by dou y. So dou m by dou x is, we need, this is our m. So if I differentiate this with respect to x, so we will have 2xy and this will be 0, right? 2xy plus 0, and here we need to differentiate with respect to y, so we have, this will be 0, so this will be minus 2x, minus already we have minus 2x, so here we have plus, will be plus 2x dy dx, right? So we need to evaluate this integral. So integral 0 to 2, integral y is equal to minus root 8x to plus root 8x 2xy plus 2x dy dx.